welcome to the channel. Today I'm going to be showing off how to connect Web3 with Dioxus. Uh, it's going to be a desktop application. So go ahead and install their CLI. It's on their page on getting started, and you should be able to follow along. I'm going to be using a Linux-based machine, but you should be able to follow along on Windows as well. So first things first, we're going to create a new project by using dx-new. Then here we get to select what kind of template we want. I'm going to go ahead and select the desktop one. And here we create the project name, which is the folder name where it's going to be stored. I'm going to call it Web3. We're going to go ahead and vanilla, but they also have Tailwind CSS. And we're going to go ahead and use the Dioxus router as well. So let's cd into Web3 tube. We're going to need additional library, which is ethers, and you can install it by running cargo add ethers. We don't need any special features, but if you do need any special features later on in your development, they're easy to add. Okay, so go ahead and open up your favorite text editor. I'm going to use Helix. So let's clean this up a little bit because we don't really care about a lot of things that are happening here. So this is a simple count, high five counter. Basically, if you click on this button, count goes up by 1. If you click on this button, count goes down by 1. Let's clear this out completely. We don't care about the blog. Strip all this naked. Let's format it out. So we're gonna need our ethers library, and specifically we're gonna need our provider. So go ahead and import those. I think it's in providers. Then it's HTTP and provider, if I'm not wrong. Okay, so after we have that import there, what we're gonna go ahead and do is use state, which is something. Okay, so state and then sharing state. So using shared state, that's what we're gonna be doing. In our top level component, which is app for us, we're gonna create our entry point for our Web3 API, so we can actually interact with the library and get access to all the functions. Just remember that it is async, so there's some extra magic we're gonna have to add. Obviously, I'm gonna show you how to do. So let's go ahead and create our provider. So we're gonna go ahead and use context here, just so we can reference this provider and all the other components. And here we're going to create a signal, and in here we're going to create a provider. It's a struct. We're going to call, going to be a type of HTTP, and then try from, and then in this try from, this is where the URL is going to go with your Ethereum API. I'm going to be using Infura. You can go ahead and use Infura as well. I believe it is free. Okay, so paste that in there. Now there's one extra step. We're going to go ahead and unwrap this and basically skip the error checking. It's kind of dangerous, but for this video, it doesn't really matter. Okay, now to call this actually in our home component, all we have to do is, but remember, it is async, so what we're going to do is use a resource. So let equals use underscore resource. We're gonna pass a closure here and then async move. So we can call our async function here. Now use context, and then what type it is. It's signal. Signal. We don't need this here. Signal provider HTTP. And now we're able to actually interact with it. We can do get block number. We want this to return here. Now this is an async, so we do dot await dot wrap. And there we go. We have a resource of U64. If we look over block number, it gets the block number. And then it returns a result with U64 or provider error. So we're not gonna match this error for the purpose of this video. I mean, you probably want to match this error. Say that, hey, you couldn't pull it from this API. Okay, so now all we have to do is just match our resource here by referencing it like so. Block or number dot read underscore unchecked. And now if we have some x, which is our block, let's go ahead and do div h1 our block. If it's none, let's do none. Okay, and that's pretty much it. Go ahead and compile. By the way, there's this issue I had compiling with the Arch-based machine. Just compile it like so. And the issue is the GBM buffer is unable to actually render anything in here. So the solution that I found is basically disabling it. Disable the DMA buffer renderer and then just passing it as an argument before you run dxserve. Should solve the issue. You're running. So our end goal should be something like this, where you can see the current block number, which is being pulled live from the blockchain. If we update this, we actually have this block right here. So thanks everyone for watching. If you have any questions or any video suggestions, I'm going to be making a networking C2 tutorial video, and just more Rust videos probably coming out in the future. So thanks everyone for watching. Leave a like button, subscribe, and yeah, see you guys later.